Hi everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is called PathSum 3. We were given the root of a binary tree and an integer target sum. Return the number of paths where the sum of the values along the path equals target sum. The path does not need to start or end at a root or a leaf, but it must go downwards, meaning it should go from the parents to the children. Yeah, so that's it. And let's take a look at the first example here. So we were given a binary tree rooted at 10, and the target sum is 8. Along the way, we have 5 plus 3, and 5 plus 2 plus 1, and negative 3 plus 11. Okay, so the output should be 3. So how should we approach this problem? If we view this binary tree as an array, we can find something similar. Okay, let's say if we have something like 10, negative 3, and 11, and we want to find the target sum equals to 8. How do we do this? Okay, 8. In previous courses, we used PrefixSum, okay? And we used PrefixSum and a hash map, okay? So PrefixSum, let's say we have here 10, 7, and 18. And now we save this PrefixSum to our hash map. So we have 10, saved at index 0, and 7 saved at index 1, 18 saved at index 2, and then we calculate the diff. Okay, so the diff with the target is 2, so we got nothing here. And here the diff with the target is negative 1, still nothing. And the diff here is 10, which is in our hash map. So we can say that the index 0, like here, if we subtract the index 0 element, the rest will be our target. Okay, so here's the same thing. We just want to count how many paths there, right? So we can save, instead of saving index in the hash map, we save its frequency. Okay, so once we hit a diff, we will add the result plus the thing in the map. Okay, else we would increment its frequency because we're hitting the same thing. Okay, so that's basically how we approach this problem. And apart from that, since this is a binary tree, we will choose a way to traverse it. So for this question, since we're going only from the parent to the children, we're using a pre-order traversal. Okay, so let's code it out. I will set up a result, initially set to 0, and I will need a map to save the PrefixSum to its frequency. Okay, next we do some sanity check. If root equals to null, we know there's nothing like that. And then we traverse the whole binary tree with pre-order traversal. And we need a current sum. Okay. After that, we can return result. So we don't need to get anything from the pre-order traversal. We're doing something inside it. So we can use a void and tree node. Okay, so the ending point, the termination condition is when cur sum equals to target sum. Okay, but before that we need to do some other checks. So if root equals to null, we can return, and if it's not null, our cur sum will add its value. Okay, and if the cur sum hits the target, we know that we have to increment our result because we're having something that satisfies our condition. Okay, and okay, next we can use our diff for calculating the result. Okay, along the rest of the tree. So map.get or default, it should be diff. Diff should be cur sum minus target sum. Okay, and before we go to the kids, the children, we should put our current sum in our map to notify the map that I've saved something here. Okay, and after we explore this path, after we explore this branch, we need to go back. So at this time, we don't want to contaminate the whole path, the prefix sum. So we have to subtract this from the map to go back to the upper layer. So this is pretty tricky here. So put in the map should put current sum get our default current sum 0 plus 1, and after that remove from the map for next branch exploration. So still cur sum and map.get cur sum minus 1. Okay, and in the middle we can go to our left child and right child. Root.left cur sum target sum and pre-order target sum. Okay, yeah, let's try to run it. So it should turn fine, and the complexity would be, since we're traversing the whole tree, the time complexity should be O(n), and of course we are doing the traversal. So the call stack should be O of H, and since we're maintaining a hash map, so it should be N. Okay, let's submit it. Oh, it gave us some wrong answer. Let's see. Oh, it's probably because integer overflow, so we can change it to long. And here we can change it to long. Let's use this test case to try. Yeah, I think it passes. Okay, perfect. Thank you so much for watching. If you like the video, please subscribe and like it. Thank you so much. I'll see you in our next video.